my dear students, welcome back to the physics class. Today we are going to start our fourth chapter, gravitation. Have you heard about gravitation? You might have studied about it in your lower classes. Gravitation is the force of attraction given by the earth. It was discovered by Sir Isaac Newton, followed by an incident happened in his life. That is, an apple hits on its head while he is sitting under the apple tree. So, let's start the chapter with the definition of force of gravity. The earth attracts objects towards its center. This force of attraction is the force of gravity. A mango falling down from a mango tree, artificial satellites revolving around the earth are some of the instances where the force of gravity is felt. So, let's look at this example. A stone of low mass and another one of slightly higher mass are suspended one by one from a spring balance. At that time, we can see that spring balance with stone having higher mass shows higher reading. That means stone with greater mass experiences greater force of attraction of the earth. On the basis of this, we can find out the factors that influence the force of mutual attraction between earth and the body. The gravitational force depends on the mass of a body, and another factor which influences the force of gravity is the distance between the objects. That means the factors affecting the gravitational force are the mass of a body and the distance between the objects. Sir Isaac Newton formulated a law connecting these factors, and the law is called universal law of gravitation. He arrived at the law of gravitation on the basis of the observations made by Tycho Brahe, Kepler, Galileo and some others. So let's see what is the law states. All bodies in the universe attract each other. The force of mutual attraction between two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That means, if two bodies of masses m1 and m2 are separated by a distance d, then F is directly proportional to m1 m2 and F is inversely proportional to 1 by d square, that is the square of distance. By combining the two, we get F is directly proportional to m1 m2 by d square, that is F equals g into m1 into m2 by d square. G is the gravitational constant used to remove the proportionality sign, and the value of g is 6.673 into 10 raised to minus 11, and the unit is Newton meter square kilogram raised to minus 2, or it can also be written as Newton meter square per kilogram square. It was Henry Cavendish, a scientist, who determined the value of G for the first time through experiments. Next one, force of gravity. If the mass of the earth is capital M and capital R is the radius of the earth and small letter m the mass of an object placed on the surface of the earth, so do you know what will be the attractive force between them? So let's see. According to the law of gravitation, we know that the force of attraction between two bodies is F equals g into m1 into m2 by d square, and here we are replacing m1 with capital M, m2 with small letter m and d with capital R. Therefore, the force of attraction between a body on the earth's surface and the earth is F equals g into m by r square, where capital M is the mass of the earth, small letter m is the mass of the body and r the radius. Here you can see the diagrammatical representation of the earth, and you can see the radius from the center of the earth to the equator is greater than from center to the pole, and we already know that the force of attraction is not same everywhere on the earth's surface because Really, Earth is not spherical in shape. The radius of Earth is not same in polar regions and in equators. The radius is minimum at poles and maximum at equator. According to this, the force of attraction also differs. And the force of attraction is maximum at poles. That means if a body placed at poles, it experiences maximum force of attraction than at equator. If a body is being continuously raised from the surface of the earth, the force of attraction decreases there. And when a body is placed at the center of the earth, it is attracted equally towards all directions. Therefore, the resultant force of attraction at the center of the earth is 0. So, thank you for watching. See you in the next video.